Hello guys, so you must have heard that every conservation law in physics corresponds to some symmetry principle. So like time symmetry is associated with the conservation of energy, because we know that if suppose we assume that what does time symmetry tell us is that the laws of physics do not change with time. So for instance, the formula for the potential energy is mass times g, which is the acceleration due to gravity times the height. So if suppose the laws of physics changes with time, if we assume that time symmetry does not hold, then suppose I can, if I put a body at some height h1 at some time t1, and after some time, say at time t equals to t2, the potential energy may be more or less if time symmetry is not valid. But that means the work which I did to take the body to that height is not equal to the work which I need to do, or the energy of the body. So that means the energy is not being conserved if time symmetry is not valid. Of course, this is not a derivation of Noether's theorem or this law that time symmetry and conservation of energy, but this is just a qualitative explanation. But similarly, if you know Hamilton's canonical equation, there is this thing that if it's in the case of cyclic coordinates, or if there is no dependence on the coordinates, basically this corresponds to translational symmetry, then that corresponds to the conservation of linear momentum. That means if what is translational symmetry, that the laws of physics also does not change if I translate a body or move a body some distance in space. Now, without going into the details of Hamilton's canonical equations or any complications, any technical mathematics, we can explain this. Even in high school, you did the derivation of the law of conservation of linear momentum using Newton's law. So in there, you assume that there are two bodies which are separated by some distance in space. Basically, but you're assuming the same law, Newton's law. You are assuming the same equation, same law in both the bodies. So without even realizing it, when you are back in high school, you implicitly assume that translational symmetry is true, because you are applying the same law of physics to both the bodies which are separated by some distance in space, that is, they are translated kind of, and by using that you actually could prove that the linear momentum is conserved. So this was just to give you a basic idea, and I hope you found the video interesting. So thank you very much.